So in the last video, we saw that by changing our notation and computing the derivative of a function at an arbitrary x, we get out another function. And we're going to write, of course, f prime of x equals 2x. So that was what we did last time. We looked at the Mathematica graph and we saw how the values of this function, right, f prime, let's say, of 3 we know is 6, and that means that the slope of the tangent line of f of x equals x squared at x equals 3 is 6. So that's the connection. So I want to do another example like that with you. This time we're going to look at the square root of x. And so let's work this out. So I want to compute f prime of x, which I know is going to be the limit as h goes to 0. I'll just go ahead and write it f of x plus h minus f of x all over h. And so this is going to become the limit as h goes to 0 of square root of x plus h minus square root of x all over h. And now at this point, this looks sort of awful, but you hopefully remember the tricks that we talked about back in chapter 1. I encouraged you, when you see a limit like this and it's indeterminate form, which this is, this goes to 0 over 0, then try multiplying by the conjugate whenever you see these radicals involved. And so let's just try. Maybe it won't work, but we're going to multiply by root x plus h plus root x over root x plus h plus root x. And so I get, oops, let me switch this to partial eraser. I get the limit as h goes to 0. When I have a minus b, a plus b, this is just the difference is squared. So I'm going to get this one squared minus this one squared. So I'm just going to get x plus h minus x upstairs, and hopefully you see that's really good news for us, times or over h times square root of x plus h plus square root of x. And so we can cancel the x's, and we get the limit as h goes to 0 of h over h square root of x plus h plus root x. And now at this point, we can cancel those h's, and so I get the limit as h goes to 0 of 1 over square root of x plus h plus square root of x. And again, the key here is to recognize that it's h that's moving. H is the thing that's going to 0. X is just some number. And so we can go ahead and let h go to 0. And when I do that, I'm going to get exactly 1 over root x plus root x, which is the same as 1 over 2 root x. And so that's the derivative of square root of x. And so we can write that down. F prime of x is exactly 1 over 2 square root of x. And so let's switch back to Mathematica again and just watch how that plays out on the screen.
All right, so same story, different function. We can see the top function is a square root of x. The bottom function is the graph of 1 over square root of x. And I want you to see the relationship between this function and this function. So we'll start our a. Oops, it throws an error when we go negative a. So we'll start our a right there. And if we slide it over, there it is. All right, so you can see the slope of the tangent line is positive. And as we drag that tangent line along, as x gets bigger and bigger, the slope of the tangent line is going to get smaller and smaller and smaller. It's sort of leveling out. And so you can see that happen here. The slope of the tangent line is getting flatter and flatter and flatter. So as you drag it along, you can watch that happening. So the y value here, this is f prime, the y value here equals the slope of the tangent line to the function f. And you can see everything play out as we drag it along. Now the graph is a little bit misleading there. It's not actually going to 0. It's just getting flatter, flatter, the farther we go.